Welcome to Next Gen Manufacturing. Today, we're going to talk about a material that's so common we barely even see it, but it's so powerful that it's right at the heart of our most advanced technology. I'm talking about glass. But wait, this isn't the glass in your window, not even close. This is glass fiber, the invisible backbone of the modern world. Let's dig into the science that turns plain old sand into an incredible super material.
Right. So when you think of glass, what's the first word that comes to mind? Probably fragile, right? Something that shatters? Well, in the world of next-gen manufacturing, that couldn't be more wrong. We're about to flip that idea completely on its head.
I mean, seriously, what if I told you that glass, the exact same basic stuff you drink your water from, could be engineered to be stronger, way stronger than some of the best steels we've ever made?
Well, it can, absolutely. See, when you take molten glass and draw it out into these impossibly thin filaments, thinner than a human hair, its properties just transform. This thing we think of as the ultimate symbol of fragility suddenly becomes a powerhouse of strength. That's reinforcement glass fiber. And it's the secret ingredient making everything from airplanes to body armor lighter, stronger, and way more efficient. Now, you gotta understand, not all glass fiber is the same. It's not one size fits all. It's better to think of it like a diverse family, where every member is tailor-made for a really specific, high-stakes job, and it all comes down to the chemistry.
So what's so fascinating here is how just a few little tweaks to the recipe create totally different abilities. You've got E-glass, which is the versatile all-arounder. Then there's S-glass, that's your high-strength hero, built for crazy mechanical stress. C-glass is like a chemical shield, designed to stand up to corrosive stuff. And AR glass, that one's alkali-resistant, which makes it perfect for reinforcing concrete. Each one is glass, but, each one has its own unique superpower. It's like having a specialist for every job imaginable.
And even though those specialty fibers are absolutely crucial for pushing the limits of what's possible, it's really E-glass that runs the show. I mean, the numbers are just staggering. E-glass makes up more than 96% of the entire global market. Why? Because its blend of pretty good strength, being easy to make, and a reasonable cost makes it the undisputed workhorse of the entire industry.
So, here's the key thing to get. It's all about the trade-off. It's a choice engineers have to make every single day. On one hand, you've got E-glass, the cost-effective standard that's perfect for tons of applications. And on the other, you have S-glass, the high-performance specialist. It's about 30% stronger, sure, but it's also way more expensive to make. So you're not going to use S-glass to build a kayak, right? You save it for something like a helicopter blade, where that material has to survive incredible forces without failing. That's where every single gram of weight and every ounce of strength matters.
So how on earth do you turn a pile of sand and other minerals into these amazing super threads? Well, the process itself is a total marvel of engineering. It's this incredible combination of extreme heat and just mind-boggling speed. Let's take a look. It really boils down to three main steps. First, you melt all the raw materials in a massive furnace. We're talking temperatures over 1,500 degrees Celsius. Hot. Then, here comes the magic. That molten glass gets pulled through thousands of teeny tiny nozzles at insane speeds, stretching it into microscopic filaments. And right as it's being pulled, a super important chemical coating gets applied. Finally, thousands of these coated filaments are bundled together into forms that engineers can actually use, like thick ropes called rovings or mats.
Okay, I want to pause for a second on that chemical coating. It's called ensamage, or sizing, and honestly, it's the unsung hero of all of this. It does two critical things. First, it protects the super delicate surface of the glass filaments from rubbing against each other and breaking. But even more important, it acts like a chemical secret handshake between the glass fiber and the plastic resin it's mixed with. This coating makes sure the two materials bond perfectly so that stress gets transferred from the resin to the super strong glass. Without the right ensamage, the whole thing would just fall apart.
And it's this perfect marriage of fiber, that special coating, and resin that is quite literally building our future. So let's look at where these hidden fibers are making the impossible, well, possible.
They are truly hiding in plain sight. That lightweight part on an airplane that saves fuel? Yep, glass fiber composite. The circuit boards that power our phones and computers, they need the electrical insulating properties of glass fiber to work properly. The armor on military vehicles uses layers and layers of glass fiber to absorb the energy from an impact. And those high-pressure tanks that hold compressed gas, they rely on the incredible strength of wound glass fibers to keep from exploding.
So here's the big takeaway. By really understanding a material on a deep, fundamental level, we can completely transform it. We took sand, one of the most common things on the entire planet, and we figured out how to turn it into a thread stronger than steel.
That just reinvented what was possible. And it leaves us with one last, really exciting question. What simple material are we going to reinvent next?